Hello students. Today's topic is the combined gas law. It's also called the general gas law. This law is the fourth gas law after the Boyle's law, Charles law, and Gay-Lussac's law. After completing this lesson, you will be able to derive combined gas law equation from Boyle's law and Charles law, and use the combined gas law to calculate changes in volume, pressure, and temperature. Students, as you remember in the previous lesson, we discussed the first three gas laws: Boyle's law, Charles law, and Gay-Lussac's law. Before we start today's lesson, let us revise the ideas of Boyle's law and Charles law, because the combined gas law is derived from the two laws. For the same number of particles in a closed container, if we decrease the volume, the pressure must increase in the container. This means that pressure and volume are inversely proportional. If one decreases, the other increases. This relationship is expressed in Boyle's law. Volume and temperature are also related. If we have gas in a balloon and heat it, the particles move faster. To keep the pressure constant, the volume must increase. This means that volume and temperature are directly proportional. If one doubles, the other doubles. This relationship is expressed in Charles' law. Today, we will see the fourth gas law, called combined gas law, which deals how pressure, volume, and temperature all integrate with each other. The combined gas law is the combination of Boyle's law and Charles' law. This law states that for a fixed amount of gas, the volume of a gas is directly proportional to its temperature and inversely proportional to its pressure. This means when the temperature increases, the volume also increases. And if the pressure increases, the volume decreases. This relationship between volume, temperature, and pressure leads us to the expression that the product of pressure and volume divided by temperature is always constant for a fixed amount of gas. So, the combined gas law can be expressed by this formula: P1 V1 divided by T1 is equals to P2 V2 over T2, where P1 V1 and T1 are the initial pressure, volume, and temperature of a gas respectively, and P2, V2, and T2 represent the final pressure, volume, and temperature of a gas consecutively. Let us do the following problems using the combined gas law equation as an example. The first example is a 300 centimeter cube sample of a gas exerts a pressure of 60 kilopascal at 27 degrees Celsius. What pressure would it exert in a 200 centimeter cube container at negative 23 degrees Celsius? The given quantities of this problem are the initial volume V1 is 300 centimeter cube. The initial pressure P1 is 60 kilopascal. The initial temperature T1 is 27 degrees Celsius, which is equals to 300 Kelvin. And as you remember from the previous lesson, we use the Kelvin scale to do all calculations which involve gases. And the other given quantities are the final volume V2 equals to 200 centimeter cube, and the final temperature is negative 23 degrees Celsius. This is equals to with 215 Kelvin. In this problem, you are asked to find the final pressure P2. As you observe in the solution part, we apply the combined gas law equation to calculate P2. And the value of the final pressure is 75 kilopascal. The second example is a sample of gas occupies 100 liters at 27 degrees Celsius under a pressure of 100 torr. What volume would it occupy at STP? Students, what is the meaning of STP? Yes, STP is an abbreviation which stands for standard temperature and pressure. At STP, the temperature of gases is 0 degrees Celsius or 273 Kelvin, and the pressure is equals to 1 atmosphere. The given quantities of this example are V1 is 100 liters, T1 is 27 degrees Celsius or 300 Kelvin, P1 is 100 torr, and P2 and T2 are 1 atmosphere and 273 Kelvin respectively, because they are at STP. But we should convert the final pressure P2 into torr, because the initial pressure P1 and the final pressure P2 must be expressed by the same unit. And the required quantity of this example is V2. As you expected, to solve this problem, we apply the combined gas law. And finally, we will get V2 equals to 11.97 liters.